coefficient can range from -1 to +1. So if you've got two risky assets, the correlation coefficient needs to be at least what for there to be gains from diversification? Needs to be less than 1. Yeah, less than 1. And you'd want it, preferably you'd want it more than just a little bit. You know, 0.99 isn't going to help much. You probably want it like 0.8, 0.5, something like that at least. So if it's less than 1, it could be gains from diversification. Now, so what if you have two assets whose correlation is 1? What's the use of buying both of those? They're, yeah, you're indifferent except for, of course, the expected return. You pick the one with the higher expected return because they're going to track each other perfectly, go up and down perfectly. Okay. Number 2, in adding a risky asset to a portfolio of many risky assets, which property of the asset is most important, its standard deviation or its covariance with the other assets?
Covariance.
Covariance, yeah. Standard deviation is important, but covariance is even more important. You remember the relation between the covariance and the correlation. You got the correlation between the returns on two assets, we'll call it X and Y, and that's going to be equal to the covariance of the returns on X and Y divided by standard deviation of the returns on X times the standard deviation of the returns on Y. Number 3, a portfolio's expected return is 12%, its standard deviation is 20%, the risk-free rate is 4%. Which of the following would make for the greatest increase in the portfolio's Sharpe ratio? Okay, first on the Sharpe ratio, expected return on a portfolio minus the risk-free rate, this would be the return on a T-bill, divide that by the standard deviations of the returns on that portfolio. Okay, so there's your Sharpe ratio. Okay, so let's start off. What's the initial Sharpe ratio you're going to have? %. Is the expected return. Standard deviation is 20%. Risk-free rate is 8%. So this would be the risk-free rate is 4%. Okay, I'm going to write it in decimal form to make it. It makes the math simpler, more easily understandable. So 0.12 minus 0.04 divided by 0.2, and that's going to be 0.08 divided by 0.2, and that's going to be equal to what, 0.4? Is that right? Okay. Now it's asking, we have a 1% increase in the expected return. So now we've got 0.13 minus 0.04 divided by 0.2, and that's going to be 0.09 divided by 0.2, and that is 0.45. B, we've got a decrease of 1% of the risk-free rate. So we'll start out with our initial return on the portfolio, 0.12 minus 0.03 divided by 0.2, and that is also 0.09 divided by 0.2, and that is also 0.45. And then C, a decrease of 1% in the standard deviation. Okay, so that's going to be 0.12 minus 0.04, and then you divide that by 0.19, and that would be 0.08 divided by 0.19, 0.42. Okay, so which one makes for the greatest increase in the portfolio Sharpe ratio? Either A or B will. So you can increase the expected return on the portfolio by 1%, or you could decrease this by 1% and give you the same result. Sharpe ratio goes from 0.4 to 0.45. Any questions on that? Okay. 8, 9, and 10. I'm going to do this in Excel, because this will help you with one of your assignments for the security analysis project. Okay, we've got 3 assets. We've got a stock fund, expected return of 15%, standard deviation of 32%. Bond fund, expected return 9%, standard deviation of 23%. Now that's obviously, that's a corporate bond fund. So it is subject to default risk. That's why it has a standard deviation. And it may be that our investment horizon is less than the time to maturity, so that's another thing that could give us volatility of the returns of the bond fund. Okay, and then we've got a T-bill money market fund that yields a sure rate of 5.5%. T-bills do not fluctuate in value very much, mainly because they are so short-term, a year or less. They could fluctuate in value a little bit if your investment horizon is less than 1 year or less than whatever the maturity, whatever T-bill you're talking about, then you could get some volatility of the returns and you can have a risk-free asset. But normally when we're talking about T-bills in this context, what it means is we're talking about you buy a T-bill that's going to mature at the end of your investment horizon. So let's say today is October 20th. I want to invest money for 1 year. If I want to invest in the risk-free asset, I would buy a 1-year treasury bill or as close to it as I could get. And there's usually one that's fairly close. Let's look at the Wall Street Journal's page real quick on that. Okay. Okay, page down, way down to here. These are the treasury bills. Yeah, we've got one there that matures in pretty close to 1 year. It matures October 12th of next year, so that's pretty close, and it gives you a yield of 0.615. Okay, so we've got here, we've got our assets. We've got our stock fund. Bond fund and our T-bill fund. And here we're going to have our expected return. Let's put that. Point, or be 15%, 9%. And on the T-bill, money market fund, 5.5%. And then we've got our standard deviation. $32.23, and for the T-bill fund would be 0. Okay, and the correlation between these two risky funds, I'll put this up here somewhere. I'll put that, the correlation between the stock fund and the bond fund, like that. 0.15. Okay, now, what we want to do is tabulate and draw the investment opportunity set of the two risky funds, use investment proportions for the stock fund of 0% to 100% in increments of 20%. And so, what expected return and standard deviation does your graph show for the minimum variance portfolio? Let me make this bigger so I can see that better. Okay, so this will be, first one would be 0% stock fund and all bond fund. Okay, so first our expected return. Okay, that's simply going to be the expected return of the bond fund, obviously. So that'll be equal to, this will be equal to E5, and the standard deviation F5. Okay, now we'll do 20% stock fund and 80% bond fund. Okay, I'll tell you what, let me put in here. I'm gonna put the weight this way I'll be able to copy it over. Okay, so here it's 0 and 1, and here it'll be 0.2 and 0.8. Okay, so the expected return, what we need is, we're going to have the weight of the stock fund times the expected return of the stock fund. So that's going to be equal to D10, the weight of the stock fund, times, and I'm going to use an absolute reference so I can copy this over to the other portfolios, E4, so it'll be $E, $4, and it'll be plus the weight of the bond fund D11 times $E, $5. D10, E4, D11. All right. I'm going to make that a percentage. Okay, for the standard deviation, I think I remember the formula, but I'm going to look it up and make sure I don't have the wrong one. Okay, here is the formula for the variance of a two-asset portfolio. Remember, the important thing here is this correlation coefficient. Because if you've got a 0, this whole here, that whole term goes to 0, or you got a negative here, since that's positive, that's positive, that's positive, this whole term here will be negative, and it'll reduce the variance. Okay, so what I'm going to do, I'm going to put formula for the variance there and then take the square root. Okay, so equals, first term is the weight of the stock fund is D10 times the standard deviation of the stock fund, $F, $4, square that, plus the weight of the bond fund, D11 times $F, $5, okay, and then plus, then we need this thing 2 times the weight, and the correlation.
Can you also use the standard deviation function?
No, because we don't have the data. You can't use Excel standard deviation function because what that'll do is it'll compute it for you from the raw data. And here we're just told what the individual standard deviations are and the weights and the correlation. From that we can compute the portfolio standard deviation. Okay, so and this last term is going to be 2 times the weight of the stock fund, D10, times the standard deviation of the stock fund, F4, I said $F, $4, times the weight of the bond fund, D11, times standard deviation of the bond fund, $F, $5. And then we need to multiply that times the correlation, which is gonna be up here, I1, times, I'm gonna make that an absolute reference also, $I, $1, 1. Okay, and then I've got to take the square root of that whole thing, because what we got right there is the variance. I'll take the square root, which is the same thing as raising to the power of 0.5. And that should, oops. Oh, okay, I see. Okay. I've got one extra parenthesis there. Okay.
Should that last two be a one?
Yeah, your I2 should be another one.
Yeah, you're right. Okay. Okay, so standard deviation 20.37. Okay, now compare that 2080 portfolio with the 0100 portfolio. And remember the criteria for dominating in terms of mean and variance. The second one has a higher mean and a lower standard deviation. Therefore, if those are the only two moments that you care about, then everyone's going to prefer that second one to the first one. And you'll notice it's lower, the standard deviation of that 2080 portfolio is lower than each one of those individual assets. And the reason for that is because of the low correlation between the two. It's only 0.15. So that's a good low correlation to have. Okay. Now let's do, okay, so what we need to do is keep incrementing it in terms of 20%. So this would be 40% stock fund, 60% bond fund, 0.4, 0.6. Now let's see if I did that right, I should be able to copy that over. Okay, now you can see this one dominates, the 4060 dominates 2080 because it has higher expected return and lower volatility. Okay, so let's see if that'll work for 6040. Okay, now here what we've got, we're getting a higher expected return because we're adding in more stocks and less bonds, but now we're getting a higher standard deviation there. Okay, and this will be 80% stock, 40%, no, 20%. Okay, so that's giving us even higher expected return and standard deviation. And then let's go to 100% stock. We already know what it's gonna be because we got, this is just basically the stock fund by itself. Let's see if that'll work, if I can copy that over. Yeah, all right. Okay, now what it wants us to do, we want to graph the investment opportunity set of the two risky funds. I often have to, whenever I do graphing in Excel, I don't know why they can't make it simpler. Whenever I do it, I always end up fumbling with it for sometimes a long time. So I might just, I'll try a little bit. If it doesn't work, I'll just draw it on the board. Okay, so I've got, what I want to do, basically what I want is, what the standard deviation of the portfolio here and the expected return here. And then you want to get something like, it won't necessarily look like that. And when you do this for your project, if it doesn't end up looking like this, that nice sideways parabola or whatever that is in the book, don't worry about it. Because you're not doing a well-diversified portfolio. You're just doing one stock against one bond. So it might end up looking like that, or it might end up looking like something weird. Okay, so we've got, let's see if I can get this to work. Yeah, see, I can't get,
You have to do the scatter, sir.
oh, the scatter?
Yes, sir.
Which one is that? It's down here?
It's the one with a bunch of dots next to this circle, the pie.
Oh, this one?
Yes, sir.
Okay.
And then it's the one with the line.
This one?
Well, you can do that one, I guess. Yeah. That one's fine. And then you have to go back and change the X and Y axis data inputs
Oh, okay.
because it's doing it it's doing it the other way around.
Okay, and then how do I change that?
Select data up on top where it shows. Actually go back to where you were just at design, I think, the chart tools.
Right here?
Yeah, and then go to select data, which is one of those options there.
Uh-huh.
And then go to edit on the legend entry series.
This one?
Yes, sir. And then right there, so you want to switch those two, the X values and the Y values.
Oh, okay, so how do I do that?
Go to the X values there in the column and just highlight all that and just delete it. That's what I do.
Just delete that?
Yes, sir.
That's all you gotta do?
Yeah. And then you highlight the data inputs that you want from the spreadsheet itself.
Oh, okay, so the X values I'd want.
It's not doing
So how do I get,
it. I think that the graph's in the way.
yeah, how do I get
So
the
move
graph?
it up.
You get to cancel that and then just cancel that again and then move the graph out of the way first.
Oh, okay. Well, it doesn't wanna- Okay,
And now you can do that. Just
okay,
the
so
same.
you go to data,
No, you go back to design.
design,
Yes, sir.
select data, okay.
Then
And then
edit.
go edit. Okay, so I've got X values, I want the standard deviation.
Okay, so
So
just
go delete the X.
Okay, delete this one first.
Mhm.
Okay,
And
and
then
then I
just
want the
hide.
standard,
Yes, sir. And then do
Okay.
the same thing for the Y values. Delete the Y values up there, and then
oh, okay. You're a lot better than this, I don't know why I can't do this.
that's it. The graph is there, and it shows it. Should just press OK, and then enlarge that.
Yeah. Okay. Well, that does give you a somewhat, yeah. Okay, there's the graph. That is kind of like what you're getting in the textbook. But don't, like I said, if what your thing ends up being something weird, don't worry about it, because it may be perfectly okay. Okay, now what we want to do, see, our risk-free rate is 5.5. Okay, the minimum variance portfolio. Now we could use the solver to try to get the minimum variance portfolio, but I don't want to go into that right now. Just looking at these, the one of choosing from these 6 portfolios, the one with the lowest variance is going to be this one right here, 20.18, which would be yeah, tell you what, okay, maybe this will work better. Okay. I don't even want that there. Okay. It's 5.5 and it's going to go up here to 2018. That is the minimum variance portfolio, and then this is it right here. Yeah, that's the minimum variance portfolio right here. Okay, to get the optimal portfolio, you want to draw a tangent line from here from 5.5 to where it just touches one of these right here. It'd probably be this one right here. That's 2.18. Well, here, let's see what the Sharpe ratio is. Let's go ahead and compute the Sharpe ratio for each of those portfolios. Okay, this is going to be equals C12 minus the risk. The T-bill rate is 5.5. That's E6. So I'll make that $E, $6. And then divide that by the standard deviation, C13. And that should give us the Sharpe ratio. Okay, here's. Okay, so the one with the highest Sharpe ratio is going to be this one right here, and that is 22, yeah. This one right here. So you draw that line. It's kind of hard to see it from here. You drew a line from here to there. It should intersect right here. And that would be the capital allocation line. And that would show you the list of possible portfolios you could get that would give you the highest Sharpe ratio. And any of those would have the same Sharpe ratio, that 0.315. And the reason why, they're all on the same line, same straight line, they all have the same, they all have the same, slope at any point on that line. So what it's gonna do is you're gonna have, here, let me- so you've got here's at 5.5%. There's gonna be a straight line up here. So this is your efficient frontier. And here's your capital allocation line, and it's gonna be tangent to that efficient frontier right here. So here's your optimal portfolio, and that one is at 60% stocks, 40% bonds. That's just choosing, and that's the optimal one, just choosing from those 6 possibilities. If we did some kind of optimization there, we might come up with a slightly different number. But I'm not going to ask you to do it for this one. All right, any questions on that? I'm glad you were here to help me with that. 'Cause when I tried to do it yesterday, I ended up with some weird line. I don't know how it ended up. Okay. So what is the Sharpe ratio of the best feasible capital allocation line? 0.315. Let's save this thing. Okay. Okay, CFA problem number 1. A 3-asset portfolio has the following characteristics. Okay, we got asset X, Y, and Z. We got the expected returns 15%, 10%, 6%. Standard deviations and weights. We got 0.5 in asset X, 0.4 in asset Y, 0.1 in asset Z. So all that we're asked to do is get the expected return on that 3-asset portfolio. Do we need the standard deviations? No, that's superfluous. Okay, so let's do this one. Standard deviation, 15, 10, 6. Expected return. And the weight, 0.5, 0.4, 0.1. Is that right? Yes, okay. Okay, so how do I get the expected return for the portfolio given those expected returns for the individual assets and the weights?
You multiply the return by the weights and add it together.
Yeah, exactly, yeah. All I gotta do, this will be equals D24 times E24. Copy that down. So the portfolio expected return that's the great thing about computing expected value or average or mean is it's a linear operator. Of course, standard deviation is not a linear operator. Just add those up, F24 through F26. And so that's going to be 12.1. All right, any questions on that? All right, any questions on chapter 6? You kind of want to go over. Yeah, I will put this up on D2L. Tell you what, we need to get started. I'm thinking better wait until Tuesday to get started on chapter 7 because I need to go over a big, long thing about the CAPM on that. So for now, what we'll do, we'll go ahead and do a quiz and then go home. Oh, you need. I'm gonna put that up on D2L.
I just did it in the wrong spot.